Hey, sixth graders, this is lesson 7-11, all about using percents to compare. We are going to be working more with percents today, calculating percents, finding how much of a percent of one number is another, solving percent word problems, and again, just using that idea of comparing percents. So let's go ahead and get started. So at the top of our page here, it says that using percents can help you compare two groups when the sizes of the groups are different. So we're going to look at the example of Appling School and Baldwin School. Appling School has 300 students, whereas Baldwin School has 500 students. And at Appling School, 45 students have the flu. At Baldwin School, 55 students have the flu. So we're going to look at the percent of which school has more kids with the flu. Not just how many kids, but like the percent of their school, which one is more infected with the flu. So we're going to look at both of these schools, and there's going to be 4 different methods we're going to use for solving Appling School. So in number 1, it says, discuss and complete these methods for calculating the percent of students at Appling School who have the flu. And remember, at Appling School, they had 300 students and 45 students have the flu. So all these 4 methods right here are all about Appling School. In a minute, we'll get down to number 2, where it asks us about Baldwin School, and we get to choose 2 of our own methods for Baldwin School. So let's start with this, number 1 for this first student. They said to figure out the percent of students that have the flu at Appling School, they did, well, F percent is 45 out of 300. The reason they did that was because they don't know how much percent is 45 kids out of 300, so that's what they're going to set it up as. F percent would be F over 100, because we don't know the number of percent, that's our missing number, and every percent is always over 100, equals 45 over 300. So for this one, you simply just solve the proportion. So I'm going to do cross multiplication, and on the left I have 100 times 45 equals, on the right I have 300 times F, which is just going to be 300F. So 100 times 45 is 4,500, and then on the right side we have 300F. So in order to have F be all by itself, we are going to isolate that variable and divide by 300 instead of multiplying by 300. We'll do the same thing on both sides, and we'll end up with F all alone on the right side, and then on the left side, we need to solve 4,500 divided by 300. Well, I know that those, when you're dividing, those zeros are the same in both of those numbers, the divisor and the dividend, so we end up basically just solving 45 divided by 3, which is 15. So if we look back at our original equation, and we said F out of 100, and F is 15, that means we got 15 out of 100, which is 15%. Or it also said F percent, and if F is 15, then the answer is 15%. All right, so this student solved it a different way. They said F percent of 300 is 45. So what they're thinking there is if 300 kids are in the school, we're trying to figure out what percent of them have the flu, and we don't know the percent. Okay, so what percent of their total kids have the flu? So they write this little number sentence with words, and they say F percent of 300 is 45. That means this percent of the total kids is 45 kids that have the flu. So just like in the first student's, their strategy, this one said F percent, which we can turn into F over 100, of always turns into the multiplication problem, is always turns into an equal sign. Okay, so basically this sentence right here just turns into symbols that we can solve. So if we try to make this a little bit simpler, F over 100 times 300 just turns into F times 300 over 100. And in fractions, I can see that 300 over 100, that's like saying 300 divided by 100, which is just 3. So I guess I should do the right side of my equation first. That stays the same. But the left side, 300 divided by 100 is just 3. So this becomes F times 3 equals 45. Another way to say that is 3 times f, or 3f equals 45. But instead of multiplying by 3, we can just divide by 3 to isolate that variable. And when we do that, we end up with f all by itself on the left side, and 45 divided by 3 is 15 on the right side. So again, if f is 15, our answer is 15%. So that's how another student solved it. Now we have our third method, and you can see they used a factor puzzle. They set it up with a part and a whole, a portion and a whole. So the portion is, we don't know the percent out of 100, but we do know it's 45 kids out of 300 total. And so this is very similar to what happened in this equation right here on the first student. F over 100 equals 45 over 300, blank over 100, 45 over 300. Those numbers are in the exact same spots. We're just going to solve it with a factor puzzle instead of with cross multiplication. So I see that these both share a factor of 100. 100 times 1 gives me 100. 100 times 3 gives me 300. Slide my 3 up, slide my 1 up. 3 times 15 gives me 45. Slide over my 15. And now we can see our missing number is 15. So this is, again, 15%. Now we have the third student who used this method. I think this method is more complicated than the other ones. You can see there's a lot more space, but it's kind of a good visual for those of you whose brains like to see it that way. This student, their thought process is trying to figure out, well, what is 1%? And then if they can determine that 1%, they can use that to figure out the percent of students that are in the school infected with the flu. So it says 300 students would be 100%. Okay, so they're kind of thinking through this like this. They're saying, well, if there's 300 kids in the school, if all of them had the flu, that would be 100% of the kids had the flu. Well, they're saying if you divide that 300 by 100, you would get 3, okay? And dividing it by 100 means you're trying to find what would 1% of the kids in the school be, okay? So 3 students would be 1% of their school. Well, it's not 3 students that have the flu, it's 45. So they took 45 dividing it by 3, and they got 15. So they said 45 students is 15 groups of 3 students, which is 15%. So again, I personally think this method is more complicated. It's a lot more to think about. It's not as straightforward as the other ones. You will not see me using this method in the rest of our lesson unless it is set up for me. I think it just takes more steps. But they did have a visual for us here, and they were saying that on the top of this tape diagram, this is the number of students. And on the bottom, this is the percent. So what they figured out was 0 students. You can see that the total tape diagram would be 300 students. Just like it started at 0% on the bottom, the total would be 100%. So what they determined was 45 students. They said, we're trying to figure out what percent is that. So they took the tape diagram and they divided it. If 300 students was 100%, then that means that 3 students was just 1%. That's what they have in blue right here. So they said, well, how do I get from 3 to 45? I multiply it by 15. So how do I get from 1% to this next one? If we also multiply it by 15, we get 15% on the bottom. All right, so we can tell that Appling School had 15% of their students infected with the flu. So our next problem says, well, what about the other school? There was also Baldwin School. They had 500 students and 55 of them had the flu. And so we're going to use 2 different methods to calculate the percent of students at Baldwin School who have the flu. So I like all 3 of these methods right here. Personally, I don't really like this one. It's not wrong. I just think it's, for my brain, it doesn't work great. If this works good for your brain, then go for it. I like the factor puzzle. Let's try that and let's see how that one works out. So if I set up a factor puzzle, and this is all for Baldwin School, so I'm going to use Baldwin School's numbers. I have a part to a whole, because remember on a factor puzzle, you must label what you're doing. I don't know the part for my percent. I'll put percent on this side and then students on this side. My whole percent would be 100%. I'm trying to determine what the part would be. But I do know my part and my whole for my students. For Baldwin School, 500 students is my whole, and the part that's infected is 55. So I should be able to solve this factor puzzle now. I can go ahead and say that 100 is a common factor. 100 times 1 equals 100, so I'll slide that up. 100 times 5 equals 500, slide my 5 up. 5 times 11 equals 55, slide my 11 across. And my missing number is 1 times 11, which is 11. And that means that for this school, 11% of the students have the flu because it's 11 out of 100, which represents 11%. So let's solve it one more way because it did say to use two methods. So I'm going to go ahead and do this method right here. So this one said F% of 300 is 45. So we're going to do a similar thing. I'm going to say F%, that means we're trying to figure out what percent of, instead of 300 kids, they have 500 kids. And instead of the infected number being 45, the infected number is 55. So in this strategy up here, we used these words and we turned them into numbers and symbols. That's what I'm going to do. So F% means F out of 100. Of in math turns into multiply. 500 can stay the same. Is in math turns into an equal sign. And then 55 just stays like that. So now I can solve F over 100 times 500 becomes F times 500 over 100. The right side of my equation does not change. Well, I know that 500 divided by 100 is just 5. So I'm going to simplify this and say F times 5 equals 55. And I already know that 11 times 5 is 55, so I can see the answer already. But I'm going to go ahead and do the strategy, just in case your eyes would like to see it. So instead of having F times 5, I'm going to make that F all by itself. So on my equation, I'm going to divide by 5 on both sides. So I'm using an inverse operation to isolate that variable. Now F is all by itself. And then on the right side, 55 divided by 5 is 11. So in both methods, we got 11%. And so what was the point of doing this? Well, right here. We want to know which school is more infected. Well, Appling School has 45 kids with the flu, and Baldwin School has 55 kids with the flu. So you might think that Baldwin School is more infected because they have more kids that have the flu. That's true, they do have more kids with the flu. But out of their total students, Baldwin School, even though they have more kids infected, they're actually doing better because they only have 11% of their total who is sick. Appling School has 15% of their total that is sick. All right, let's move on to our next page. So on this next page, the first 4 problems are not word problems. They are just having us practice turning a word sentence into something that we can calculate. So for number 3, I'm going to rewrite this with numbers and symbols. And I would like to point out that when they say is and of, those are going to be really important for us. Is in math is going to be equals. Of, we already know, is going to be multiplying. Okay? So if it says is and of, those are going to be important for us. It's going to be equals and multiply. Also, I see of in these 2 problems, so those are going to be a chance for us to multiply. And I see is. Now, the reason this is so important that you remember this, hopefully from my class you've already learned that of means multiply, but is actually something important too. It means equal. This is important because you can translate a sentence into math that you can actually solve. So I'm going to solve number 3 at the top here. And I know I'm going to run out of space on this page already, so I'm going to try to cram it in at the top. So I'm going to do number 3 right here. Okay, 26, so I'm going to write the number 26 is, so I'm going to put equals, what percent? Now when we're trying to do what percent, that means I don't know the percent. So I'm going to put X out of 100, because that's how you can write a percent, is you can put the number on the top of your numerator, and then for your denominator, just 100. That's how we deal with percents. Of, I'm going to put a multiplication symbol, and then 130. So now I have all the information I need to solve this. So I'm going to simplify it a little bit. 26 can stay the same, equals X times 130 over 100. Okay, I had to edit the video for a second because I made a mistake and I don't want to teach you guys the wrong way. Okay, so what we have here is 26 equals X times 130 divided by 100. And in order to start making this more simple, I'm going to multiply this side by 100 so that I can get rid of that denominator, but I have to do the same thing to the other side. That's what algebra is all about, is whatever you do to one side, you must do to the other side to make it your equation balanced on both sides. So this ends up going away because they kind of cancel each other out. And then on the left side, we have 100 times 26, which is 2,600. I'm running out of space. I'll do it over here. Equals X times 130. So I'm just going to put 130X. Here, this is getting crowded. There we go. So now I can solve by isolating my X and saying I want to divide by 130 on both sides. And then that leaves my X all alone on the right. And then on the left, I get 2,600 divided by 130. Well, I know 26 divided by 13 is 2. And then I'm going to have an extra 0 in there when I'm all done. So, and you can do that off to the side if you want to actually do your division there, but it's 20. So for this one, X is 20. Let's try that on number 5. 5 is going to be, or I shouldn't have done number 5. Number 4 is the next one. Okay, so the next one says 25% of what number is 225? So we're going to turn this into a sentence that we can actually solve. So 25%, we're going to put 25, 100. We can write it as a fraction. Of, we can put a multiplication symbol. What number? That's a question mark. We don't know, so we can put X there. Is turns into an equal sign. 225. So basically we turned this word sentence into a number sentence that we can solve. So let's see. I think this would be a little bit simpler if I went ahead and simplified. 25 out of 100 I know is 1/4. So I'm going to put 1/4 times X equals 225. I'm going to simplify again because I want this fraction to go away. So I'm going to multiply it by 4 over 1. Now 4 over 1 is just 4. So I'm just going to multiply the right side by 4. Because whatever you do to the left side, you have to do to the right side. So these fractions end up canceling each other out. And our X is isolated. It's all alone. And the right side is 225 times 4. Which I don't know. 225 times 4. Could probably figure it out in my head because 25 times 4 is 100. 200 times 4 is 800. So it's probably 900. But I'm going to check. 5 times 4 is 20, 4 times 2 is 8, 2 more is 10, 4 times 2 is 8, plus 1 more is 9. Yeah, we got 900. And there we go. X equals 900. Let's do our next one. So for number 5, it says, what is 75% of 280? So we're trying to figure out the answer for number 5. And we'll say what is, we don't know, x is, so we'll put the equal sign, 75%, which we can write as 75 over 100, of, we can put the multiplication symbol, 280. All right. So I think the first thing I'm going to do to make this a little bit easier is simplify my 75 over 100, because that's going to simplify to 3/4. So 3/4 times 280. So this just turns into some number crunching now. I can multiply 3 times 280, because remember, we can just make this over 1, right? So I'm going to solve, my denominator I already know is going to be 4, but I need to solve 3 times 280. So I get 0, 24, 6, 7, 8, get 840. So I need to solve 840 divided by 4 to get my final answer of what x equals. So I'm going to do that right here. 840 divided by 4. 4 goes into 8 2 times. Subtract and we get 0. Bring down our 4. 4 goes into 4 1 time. 1 times 4 is 4. Subtract and we get 0. Bring down our 0, and we just end up with 210. So x equals 3/4 times 280, which is 840 divided by 4. 840 divided by 4 is 210, which is our answer. Okay, we have one more we need to solve. Do we have room to solve one more? I hope so. There's not a lot of space to do this on this page. Okay, 70%. So I'm going to write that as 70 over 100 of means multiply. What number? We can put x. Is, we can put equals 595. We'll just write 595. Okay. 70 over 100, I'm going to simplify that to 7/10 times x equals 595. All right, now to get rid of my fraction here, there's a couple things you could do. You could multiply this by the reciprocal, which would be times 10 over 7, or you could multiply it by, I'm going to do that. I think that's the easiest. So I'm going to multiply it by 10 over 7, which means I also need to do that to the right side, times 10 over 7. So this all cancels out, and I'm left with x, and my answer is going to be 595 times 10, which is 5,950, and I need to divide it by 7. So if I can solve this problem, I'll get my answer. So let's do that. 5,950 divided by 7. So 7, how am I going to get there? Let's see. 7 times 9 is 63. That's too big. 7 times 8, that'll get me there. Gives me 56. Subtract and I get 3. Bring down my 5. 7 times 5 is 35. And bring down another 0. 7 goes into 0, 0 times. So we ended up with 850. Oh, okay, so these problems, 3, 4, 5, and 6, they just take lots of careful algebra skills. You have to understand how to turn these word sentences into a number sentence. Excuse me. And then you have to understand how to isolate your variable. Make your x all by itself to get your answer. All right, now we get to move on to these word problems. Okay, I'm going to kind of mark this off because this was up here for number 6. Okay, so for number 7, it says, a company spent $4,500 of its $18,000 advertising budget on internet ads. What % of its advertising budget did the company spend on internet ads? Wow, sorry. My allergies must be bothering me today, guys. My voice keeps getting all messed up. I have to keep clearing my throat. It's probably really annoying to listen to. Sorry. Okay, so they spent $4,500 of, which I know I'm going to have to multiply. It's $18,000 on internet ads. What percent of its advertising budget did the company spend on its ads? Okay. So what we can do here is we could say we're trying to figure out the percent. We don't know the percent. So we can say X out of 100. And then we can multiply that by 18,000 because that's their total advertising budget. Okay? And that is, gosh, why did I write it there? There was not enough space to do that. Sorry. Is 4,500. Okay, so why did I choose to set it up like this? Because they're telling you that $45 of its $1,800 is what they spent. Okay, so we're trying to figure out what percent that was. So we don't know the percent of their total, but we do know that it was $4,500. Okay, so some percent of their total was $4,500. Okay, so if we want to solve this, what would be our best method? Well, I think I want to get rid of this 100. So I'm going to multiply by the 100 to get rid of it. So times it by 100 so it goes away. I'm going to times this by 100 because you have to do the same thing on both sides. And so now we have X times 18,000 equals 4,500. There's a 4,500, but if we multiply it by 100, we get an extra 2 zeros. That's really big. It's 450,000. Goodness, that's huge. So if I want X to be alone, I need to divide by 18,000. I will do the same on the right side. And we end up with X, because 18,000 divided by 18,000 is just 1, so X is all alone. And now we have 450,000 divided by 18,000. That seems like a really big problem. Well, I know in division, my zeros are going to end up canceling each other out here because they are all dividing by the same thing. So basically, I can make this simpler by doing 4,500. Or sorry, not 4,500. I crossed that one out. 450 divided by 18. So that's what I'm going to do to make this easier. 450 divided by 18. 18 times 2 is 36. Subtract and we get 9. Bring down by 0 and I have 90. How many 18s go into 90? Ooh, I don't know. I know if 18 is close to 20 and I can fit 5 of those into 100. So it's a little bit less than that, so I'm going to try. And hey, I get exactly 90. That's perfect. So it ends up being 25. So all that crazy math, X ended up being 25. And so what percent of its advertising did they spend on internet ads? Well, if it's 25 out of 100, we end up with 25%. All right. Number 8. If 30% of a company's advertising budget is $7,200, then what is the full advertising budget? Okay. So I see of, that's going to be multiplication. I see is, that's going to be equals. So if 30% of their budget is $7,200, then what's their full total? Full would be their total. Just writing some notes here so I can understand what's going on. Okay. So 30%, I can write that as 30 out of 100. I can put multiply 30% of their total budget. Now we don't know their total budget, so that's where our X is gonna go, is equals 7,200. So we just turned this word problem into an equation, and now we can solve it. So I'm going to make it simpler. Instead of 30 over 100, I'm going to simplify that to 3/10 times X equals 7,200. Oops, I forgot my 2. 7,200. That looks really weird now. I should just rewrite it. Okay, then in order to isolate my X, I need to multiply by the reciprocal, which is 10 over 3 instead of 3/10, but I have to do the same thing to both sides. All right, so this goes away, and X is all by itself, and we end up with 7,200 times 10 divided by 3. Well, if I multiply it by 10, it gets an extra 0, and then we need to divide by 3. 72 divided by 3, and then we'll put 3 zeros on our answer. Okay. 72 divided by 3. 3 goes into 7 2 times. Subtract, we get 1. Bring down our 2. 3 times 4 is 12. So we get 24. X equals 24. 72 divided by 3 is 24, but then we have some zeros we need to take care of. There's 3 of them. So there should be 3 in our answer. So X equals 24,000. So we're going to put that for our answer. It's in money. Their full advertising budget was 24,000. All right, number 9. We don't want our work to get too complicated here. All right, number 9. Another company's advertising budget is $7,200. The company spent 30% of their budget on newspaper ads. How much did the company spend on newspaper ads? Okay, so we've got is, which means equals, of, which means multiply, and now we can use that information to set this up. Okay. So their budget is 7,200. That's their total. They spent 30% of that budget. Okay, so 30% we can write as 30 over 100. Of is going to be multiply. Their budget. Well, it says their budget is this, is 7,200. So our job is to figure out how much this was. What is 30% of 7,200? All right, well, it'll be a little bit easier. The answer is going to be what we're looking for. If we change our 30 out of 100 to, say, 3/10, make our math a little bit smaller. And I'm going to multiply 7,200 by 3, and then whatever our answer is, we will divide it by 10. So let's solve 7,200 times 3. We get 21,600 divided by 10 equals X. And I know that in division, if they both have a 0, those end up not really mattering. So we end up with 2,160 over 1, which is just 2,160. So that's our answer, equals X. So 2,160. All right, number 10 says, if the gasoline ethanol mixture made with 24 liters of ethanol is 15% ethanol, then how many liters is the whole mixture? So we're trying to find the total. Okay. Let's see. They've got 24 liters of ethanol. Let's... Oh, okay. So what we're going to do here is, we could set up a proportion if we wanted to. We haven't done it that way in a while. We could say 24, because that's their mixture. And then on the bottom of our proportion, we could put E. We can say that is 15 over 100, since it's 15%. Okay, so we're saying that the part, I guess I should label my proportion here, my part to my whole is 15 out of 100 because it's 15%, but then my ethanol, 24 is the part. We're trying to figure out what is the whole mixture, what is the total. Okay, so if I want to solve this, I can just cross multiply. And when I cross multiply, I get 15 times E, which is 15E. And then on the other side, I get 24 times 100, which is 2400. So if I want to solve and get my answer for E, I need to divide by 15 on both sides. So the E can be isolated and all alone. So I need to solve 2400 divided by 15. 15 goes into 24 one time. Subtract and we get 9. Bring down our 0. 15 goes into 90. I think I need to start skip counting. 15, 30, 45, 60, 75, 90. So I end up with 6. Okay, so 6 times 15 is 90. I just solved that. Nothing left. Bring down a 0. 15 goes into 0 0 times. All right, so we end up with 160. So when it says how many liters is the whole mixture, in our proportion, the part that was missing is 160. So 160 liters, or you could just put a capital L to abbreviate it. All right, so 11 is a two-part problem. It says if 3 gallons of antifreeze is mixed with 2 gallons of water, then what percent of the mixture is antifreeze? Okay, so if 3 gallons of antifreeze is mixed with 2 gallons of water. So let's do antifreeze versus water. So 3 gallons of antifreeze versus 2 gallons of water. What percent is antifreeze? That's what we're trying to figure out. So X over the total. Oh, we can't do, sorry, the way I just set this up, I was thinking you can't do the total if you're doing antifreeze versus water. So instead of 3 to 2, it should actually be antifreeze to total, not antifreeze to water. The reason that we're changing this, I just realized, I was thinking, because if we're going to do a percent, the percent is part to whole. And we don't know what the part is in their percent, but we do know that the whole is 100. So for the antifreeze is 3, and the total, instead of just the water by itself being 2, we want the total, which is the antifreeze plus the water. So the total is antifreeze plus water, which is 5. So my bottom fraction is going to be 5 here. And what will that end up being? All right, so I'm going to use some cross multiplication. And on the left, I have 5x. On the right side, I have 3 times 100. So I have 5x equals 300. Divide by 5 to isolate it. Do the same thing on the other side. 300 divided by 5. Let's figure that out. Oh, I wrote 500. I meant 300. 5 doesn't go into 3, but it goes into 36 times. 6 times 5 is 30. Subtract, get 0. Ah, perfect. It's 60. So x equals 60, which means what percent of the mixture is antifreeze? 60%. So now, if we want to do what percent is water, there's 2 ways we could do this. We could set up another proportion and say instead of antifreeze versus total, it could be water versus total, and water would be 2 parts because it says 2 gallons of water. The total would still be 5, and then do x out of 100, and we could solve that same thing, except I know that if this is the same problem, if 60% is antifreeze, then the rest must be water, and the opposite part of 60 would be 40. So if 60% is antifreeze, there must be 40% left to be water. And I don't have to do all of this stuff because I could just do, well, 100%, take away the 60%, you're left with 40%. All right, so our last part. If a pharmacist needs to mix 800 milliliters of antibiotic with water so that the mixture is 40% antibiotic, then how much water does the pharmacist need to add? All right, well, one thing we could do here is set up a proportion. Let's see, we could say 800 milliliters, and then we can call it M for the mixture. Okay, so 800 over M, and we can set that up to be 40 out of 100. Now, why did I pick 40 out of 100? Because of 40%, okay? So it's kind of like the problem we just did with the antifreeze and the water mixture, but this is antibiotic with water mixture. So again, it's like saying your part versus your total, and the antibiotic is our part. There's 800. The total is what we're gonna try to figure out in a little bit. So it's 800 milliliters of antibiotic, and the total we don't know yet, but we do know that the mixture is 40%. So 40 over 100. So let's solve to get the total first, and then we'll figure out the water in just a second. So let's do cross multiplication. We can do 40M equals 800 times 100. So 40M equals 80,000. And then to isolate our variable, we can divide by 40. And then M is all by itself. And then we have 80,000 divided by 40. Well, 80,000 divided by 40, I know that 8 divided by 4 is 2. And then these two zeros, if I did the division, would just cancel each other out. So we are left with 3 zeros. So that means that this is not our answer, but this is going to help us get to our answer. We have M equals 2,000. Now M is our total mixture, okay? So there's 2,000 milliliters in the total, okay? So how does that help us? They say, how much water does the pharmacist need to add? So if the total is 2,000, and we're going to take away the antibiotic, and that antibiotic was 800, then we will be left with water. So the total, take away the antibiotic, so 2,000 take away 800 equals 1,200. So the question was, how much water does the pharmacist need to add? 1,200 milliliters. All right, now that is it for this lesson. Now, to be honest with you guys, I think this lesson is tough. I think it's one of the hardest ones that we have done. I think that these problems are tricky because there's so many things to think about, and it's hard to know how to set up your equation. So do the best you can. If you end up needing more help, you let me know. Thanks, guys.